Assalamualaikum, good morning. Boleh dengar?
Waalaikumsalam, boleh.
Dengar?
Hello, Prof.
Kita boleh mula? Boleh mula? Hello?
Boleh, Prof.
Okay, terima kasih. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good morning. Welcome to the class skee3133. Okay. So today I will discuss on the topics for the subjects. Okay. System modeling and analysis. And I will talk about introductions, objective and synopsis, the outcomes, the syllabus, the lecture planning, assessment and timetable, and references. So lecturers for today is me. Okay. Is a long last call for me to fill up the job because nobody takes us. Okay, for the subjects. Anyway, I will try my best to assist you, to help you. Okay, to understand these subject matters. Okay. Because this is the basic control systems, okay, and after you pass this subject, you will go for the control system design. Then after you pass the control system design, then you will go for the advanced control in the elective subject. So graduate in electrical engineering 1989, masters in control system 1983, and instrumentation in 1996. more or less about 31 experience as a academicians. I used to be the head of department for the off-campus program, for space program, nearly 10 years, and the head department of control and instrumentation for 2 years, then academic master's support course for 2 years, and the dean of UTM space from 2015 to 2018. So how to contact me is based on email. Okay, there's my email, FUA'AD@fke.utm.my, or my phone, or through my website also can. And you can refer to my URL, the Google Scholar publications, and especially the 3133 website. Okay, so when you click the link here, so it will channel you to the website of my subjects matters, which is system modeling and analysis. So these subjects, actually we have 3 center, one in JB by Dr. Herman, and the KL and KK is combined or consolidated, okay, between KL and KK. KL about 31 students, KK is about 10 students, so total number is 41 students. But unfortunately, the attendance is about 26 students, meaning that the remaining students still sleeping or maybe busy, okay, or not aware of the first class. And the coordinator is Dr. Fatima Shah. So the objectives of this subject is to expose the student regarding the theory of the modeling in control system using classical control principles, okay, to introduce students to the basic concept of analysis of control system in time domain and frequency domain. So the synopsis, okay, we will talk about the fundamental ideas and definitions of control system in terms of the open loop and closed loop, transfer functions, transient analysis, and steady state response. Then we will look into the mathematical model for the physical system using a transfer functions, and then we will look into the system representations using a block diagram and signal flow graphs. Then we will go on the technique in analyzing control system performance and stability in time domain. And we will go to the system performance and stability in frequency domain. Okay, so we have 2 domains, time domain and frequency domain. And finally, some introductions to the analysis using software MATLAB. Okay, so you have to install the MATLAB software, okay, in your laptop in order to do the assignments and to solve some problems in the class. So for these subjects, we have about 4 course learning outcomes. Okay, so at the end of the course, the student should be able to first, CL1 is to apply the knowledge of basic control theory, to describe the structure of control system design and control system representations. Then to apply the knowledge of mathematics, science, and electrical engineering to derive the mathematical models in the form of transfer functions of electrical and mechanical and electromechanical system. Electromechanical is a motor system, okay, a DC motor system. Then CL03 is to employ the transfer function of the control system to illustrate the performance and stability in the time and frequency domains. And lastly, CL04 is to use MATLAB software in analyzing control system performance and stability. Okay, so total we have about 4 course learning outcomes. Okay, when you pass this subject, you should get these outcomes. Okay, as you know that for the program learning outcomes for the electrical engineering students, we have 12. Okay, PLO1, PLO2, PLO3. PLO1 is on the knowledge of mathematics, science, and electrical engineering. PLO2 is able to conduct experiments, okay, and interpret data. PLO3 is more towards the modeling, or formulate, investigate. PLO4 is appropriate to use tools and modern software, okay, such as MATLAB. PLO5 is more towards design, okay, the complex system. So PLO1 and PLO till PLO5 is related to the technical knowledge and competencies. While PLO6 until PLO12 is related to generic skill. And usually for these subjects, we emphasize on PLO8, okay, to recognize the need and preparation ability in the lifelong learning, more towards reporting, more towards presentations of assignments. So if we're mapping the course learning outcome and the program learning outcome, the four CLO that we listed previously, CLO 1, 2, 3, and 4. So we can map to the 12 PLO12 PLO. So not all. So it's here where you have 1A, 1 meaning that the CLO1 is mapping to the PLO1, and we have tests or exams, okay, to test your understanding. Then CLO2 is for PLO1 as well, okay, have a test, and CLO3 is one. We have a test, meaning that for these subjects, because it's the early subjects of the electrical engineering courses, so it more emphasis on the PLO1. Then PLO4 is for the usage of MATLAB, okay, in the subjects, in the assignments. So the timetable for this particular subject is shown here. So please refer to the green color, okay? So the green color indicate skee3133. So we have on the first week, okay, second week, minggu keempat, minggu ketujuh, 2 kali, minggu ke-13 dan minggu ke-15. Okay. So today class is on Sunday, so start at 8:30. So we'll be finished by noon. Okay. Then next week is on the Wednesday from 2 until about 7 or 8 o'clock. Right. So Kota Kinabalu and Kuala Lumpur will share the same slot time, okay, the green color. So if we summarize the timetable, okay, so it will be like the week 1, 14 March, which is today, 8:30 to 4, 6 hours. Week 2 is on the 20th of March, next Saturday, 2 to 10 p.m., 6 hours. And then week 4 is on the 4th of April, 8:30 until 4, 6 hours. Then in between 4 and 7, there is Ramadan, okay, which is on the 13th of April, 13 April Ramadan. So week 7, 24th April is the Ramadan time, okay. So So the class will go as usual as 2 to 10 p.m. So maybe we can make it short until 6 p.m. Then we will let you go for the iftar or buka puasa. Okay. Then 25th April also is Ramadan time, which is I'm sorry about this. Number 7 is salah. Patutnya dia adalah 8.30. Sorry, yang ni 25 April ni patutnya 8.30. Bukan pukul 2 silap. Nanti saya betulkan. Okay. So 24 dan 25 ni adalah kelas di dalam bulan Ramadan. So I hope everybody can attend the class. Okay. No excuse for Ramadan. Then after that, it took about lama juga. Okay, dalam bulan Mei tak ada kelas. Okay, the whole Mei tak ada kelas. Dan sambung pada bulan Jun, minggu ke-13 dan 19 Jun pada minggu yang ke-15. Okay, so ada silap sikit dekat nombor week 7 ni. 25 April ni, hari Sunday, bukan pukul 2, 8.30 hingga 4. Okay, sorry for that mistakes. So for the assessments of the SKE3133, we have test 1, 15%, which is on the week 4, 4th April 2021, Sunday 2 p.m. So the test will be online using UTM Space e-learning. Okay. So the question will be uploaded in the UTM Space e-learning, okay, and will be open on Sunday 1:30 p.m. Okay, then you can download and open the question with the password given. Then you have to answer online with video on. So video must be on, okay, to show your face and your hand during writing. So the scope of test 1 will be chapter 1 and chapter 2. And then test 2 will be on the week 15, 19th of June, which is on the last class, okay, and Sunday 2 p.m. as well. Scope will be chapter 3 and chapter 4A. And then the assignment, which is 20%, which will be released in the 14th April 2021. Okay, final exam is on July 2021, which is 50%. So total is 15 plus 15 plus 20. So it will be 50% carry marks and then plus 50% final exam. So you will get the whole subjects, okay, 100%. So let's go to the briefly on the chapter 1, the introduction to control system, which will be on 3 hours lecture. Okay, we will look into the history of control system basic, control system configurations, examples of control system and control system design. Okay, so basically we will learn about this block diagram. Okay, the feedback. Okay, the open loop, the forward path, the input and the output. And the chapter 2 is the more mathematical modeling in transfer function form, okay, which will be introduction to Laplace transform, transfer functions, modeling of electrical systems, modeling of mechanical systems, modeling of translational system mechanical, rotational and rotational with gear, and modeling of electromechanical system. Okay, so dia banyak formula kat sini dalam chapter 2. So chapter 3 is more towards system representations, which is 4 hours. We will look into a block diagram and signal flow graph and technique to simplify the block diagram. And then changing from signal flow graph to block diagram, and block diagram to signal flow graph, vice versa, using a Mason's rule. So chapter 4 is quite long, so we divide into three parts. Chapter 4A, which is the response analysis in time domain, okay, which include the system categories, poles and zeros, system response, standard input test signals. We will look into the first order system, okay, then the second order system, okay. So of course, first order system is the system yang paling mudah sekali, the simple one, and second order system is the more advanced compared to the first order system. Then we will look into the third order system, system response with additional poles and the steady state error that happen in control system, okay, the definition, the test input signal, and the how to calculate the error. So the second part of the chapter 4 is chapter 4B, which is the stability analysis in time domain. So we will look into the introductions, the relative stability based on pole locations, method to test stability using a Roth-Weiss criterion, stability analysis, and MATLAB session in 3 hours. Chapter 5. Chapter 5 is the response and stability analysis in frequency domain. So which will be in 9 hours, okay? So how are we going to stabilize the unstable system using a frequency response approach, okay? And we will use the both plot analysis, stability analysis, gain adjustment, and try to make a relation between the closed loop and the open loop system, okay? And some steady state error in the frequency domain. So the lecture planning, I divide into seperti yang ditunjukkan. Okay, actually this one for perdana, but for PTM space usually week 1 ni kita kira macam hours lah. Kalau week 1 ni 3 hours, week 2 3 hours. So as for today, we try to cover the week 1 and week 2. Okay, then week 3 nanti dekat kelas yang lagi satu pada hari Sabtu depan. Okay, maknanya week ni dalam dia ada 3 hours. Week 1 3 hours, week 2 3 hours, week 3 3 hours, and so on. Okay, so kita divide dia sampai kepada minggu yang ke-15. Okay. So tolak 1 minggu lah. Week 8 ni dia semester break. Semester break ni macam cuti lah, tapi you all tak ada cuti . So consider this one 14 lah, instead of 15, 14. So 14 darab 3, 42 jam. So learning resources, you can use a teaching module, which will be distributed using a Google form. Okay, some of the students already ordered, and the secretariat take note about it, and they will take action by this week, inshallah. Okay, so teaching module is dia macam atas sikit daripada slide. Okay, slide tu ringkas, teaching module tu dia lebih detail. Okay, and then normalize control system pun bagus juga. So if you don't have money to buy, you can I will make a book chapter on certain chapters of the lecture so that you can read from the book chapter. So Ogata, Dwarf, and Bishop is some extra references that you can use for this subject. And for programming, you can use this book, Dukibati, Analysis and Design of Control System using MATLAB. So it is available in the internet. Okay. So I think I have the ebook I can share with you in the WhatsApp list. Then Benjamin Ko and Ogata MATLAB also available for extra references. So this is the teaching module that I told you before. Okay, so those yang berminat, sila isi Google Form. Okay, then do the transfer to the Maybank account of me. Then I will forward the payment to the secretariat for posting. So as I told you before, Normalized Control System Engineering book is the highly recommended book. Okay, so you can get in the library, you can get from the bookshop, or you can download from the internet if you want. It's available. Second one is the Modern Control System by Dove and Bishop. Okay, also a good book. Then Ogata. Okay, Ogata is the book that I used during my undergraduate study at UTM in 1980s, 1980-an. The first book of control system from K. Ogata. Then Benjamin Ko, also a good book. Okay, the late Professor Ko. Okay, this is more towards American style of teaching. Okay, by Benjamin Ko and FUA'AD Bulnaragi. And we will use the e-learning for the notes uploaded in the e-learning. Okay, and then the test 2, the assignment, the final exam will be used e-learning, UTM e-learning, UTM space e-learning, sorry, UTM space e-learning to get the questions, submission assignments, and so on. So nowadays we have a lot of choice, okay, to do self-learning from books, from the slides, from the teaching module. Then you have YouTube, okay, by certain lecturers. So I recommended Brian Douglas, okay, it's a very good video, very good lecturer. Can explain the theory of control system. Okay, you can click to the link as shown. Then that is the end of my introduction slides for this class. So is there any questions from the student? Ada soalan? Ada soalan nak tanya? Silakan.
Tak ada setakat ni, Prof.
Tak ada? Takkan tak ada soalan? Tanyalah. Ada soalan? Ada pelajar Kota Kinabalu sini? Ada tak?
Ada, Prof.
Eh?
Ada.
Sama kan? Jam sama, 8.30 kan? Waktu sama?
Waktu sama jam 9.
Ya, okay.
Ya, Prof.
Kenapa nak tanya, awak ni semester baru daftar ke ataupun dah semester 1 dah ada kelas sebelum ini?
Maksud semester 1
Maksud
ini
saya, adakah ini first time ataupun sebelum ni dah masuk kelas pada SEM 1 yang lepas?
ada masuk sem lepas.
Oh, dah masuk SEM lepas.
Ah,
Ini maknanya semester kedua lah.
ya betul.
Sama, pelajar KL pun sama? Pelajar KL pun sama?
Sama.
Tanyalah apa soalan nak tanya. Setuju ke, tak setuju ke? Assessment.
Prof,
Silakan.
so this semester our class semua online lah kan?
Iya, kelas online. Tidak ada face to face.
Oh, okay.
Cari software MATLAB tu supaya kita boleh gunakan dalam kelas. Boleh tak usahakan?
Boleh, Prof. Boleh.
Ya. Ada soalan?
Tiada ada. Tiada, Prof.
Ya dah.
Ya.
Okay.
Prof, nak tanya satu Prof, Razali. Untuk
Silakan.
final nanti online ataupun face to face
Final exam so far online. Belum ada notice kata face to face.
Sebab kalau dimaklumkan kan sekarang by April kan student dah mula masuk universiti tak?
Tak semua boleh masuk. Ada certain pelajar saja. Final year, pelajar yang ada lab yang tak boleh online punya lab kena datang. Tak semua boleh masuk.
Okay, thank you.
So kita tengok nanti Julai, sebab Julai lambat lagi, sekarang baru bulan Mac, bulan 3. Ada lagi 4 bulan lagi. Okay. Jadi kita tak tahu situasi yang sebenar. So sekarang ni kita beri panduan base kepada keadaan yang sedia ada. Okay. So apa-apa perubahan saya rasa tidak ada online lah, kalau maknanya tidak ada face to face lah. Mungkin bulan 10 nanti baru boleh face to face. Tapi tak tahu macam mana SOP-nya. Okay. Mungkin dia separuh-separuh kot. Separuh face to face, separuh online dan sebagainya. Okay, kalau tak ada soalan, kita pergi kepada apa nama ni, yang seterusnya. Sekejap ada pelajar ni yang lambat masuk dan sebagainya. Jadi kita pergi kepada chapter 1. Okay. Nampak tak chapter 1?
Okey, nampak.
Nampak.
Nampak, Prof.
Okay, so kita pergi kepada introductions, chapter 1 of system modeling and analysis. So one of the significant icon in control system is the high speed train. Okay, seperti yang ditunjukkan. Okay, high speed train ni dah banyak dah. Dulu kat Jepun je. Sekarang dah ada dekat Korea, dah ada dekat China. China dah banyak lah. Jadi Malaysia tak ada. Patutnya Malaysia dah lama ada. Tapi disebabkan oleh keadaan yang tidak mengizinkan, so banyak perkara yang tertangguh. Okay. So high speed train ni is one of the good example of a control system. Okay. So ada yang menggunakan magnetic leaf, ada yang menggunakan current, ada yang menggunakan power electronics and so on. So dia banyak elemen kontrol di dalam tu. Jadi saya akan bercakap tentang control system basic, history of control systems, control system configurations, example of control systems, analysis and design objectives. Okay. And then simulation software in control system in MATLAB. So the basics of control systems. So biasanya kita lihat ada dua benda yang kita boleh kawal. Satu adalah kapal terbang, okay. Satu lagi adalah Mother Nature, okay. Ataupun taufan atau puting beliung. Yang ini susah kita nak kontrol sebab dia adalah Mother Nature. Okay. Allah SWT dia yang boleh kontrol. Tapi kapal terbang kita boleh kontrol. Okay. Kita boleh naik berapa tinggi pada ketinggian yang tertentu, kita boleh take off, kita boleh landing dan sebagainya. But if the equipment in the flight is rosak, maka kapal terbang akan tidak boleh terkawal dan dia akan out of control dan dia akan menyebabkan naas. Okay, so what do these two have in common? Satu adalah highly complicated dynamics, which is the flight. Dua-dua pun sama. Both are capable of transporting goods and people over long distance. Jadi yang ini boleh bawa orang daripada satu destinasi kepada destinasi yang lain. Yang ini boleh bawa orang, taufan ini, tapi tidak ada destination yang tetap lah. Maknanya ikut pada kekuatan angin tersebut. So you can see that the aeroplane can be controlled and apa nama ni, taufan ini is tak boleh control. So control is the hidden technology, okay, that you met every day in your life. So control system are important. They present almost everywhere in our daily life. For example, in the port, we are using a crane. For the import-export, kita ada what you call that container 40 kaki dengan 20 kaki. So semua ni diangkat dengan menggunakan control system, crane, magnetic and so on. Okay, so some of the examples of control system is washing machines, radio, antenna, missiles, robots, and the simple one is the room air condition system. Okay, yang ada kat rumah kita dan yang ada kat office kita. So sebenarnya control system ni adalah ciptaan Allah. Okay, dan manusia kena pandai gunakan dia untuk kebaikan. So control system provides output or response for a given input or stimulus. That's why a control variable determine the input and output of the control system. Okay, so the input we call it as a stimulus, the desired response, and the output is the response of the actual response. Macam kita naik elevator ataupun naik lift, kita masuk dalam pintu lift, masuk dalam lift, kita tekan button pada desired level yang kita nak. That is the input. Then actual level of elevator is the output. Then elevator level is the control variable. So dia berdasarkan kepada diagram ini, iaitu dia ada controller, dia ada actuator dan dia ada plant. Plant tu adalah dia punya sistem lah, proses dia. Dan actuator adalah subsystem, anak kepada sistem itu. Actuator ni adalah penggerak. Dia adalah, kalau kita translate, dia adalah penggerak, benda yang bergerak. Contohnya valve, tutup, buka, motor, berpusing atau tidak. And then dia ada controller. Okay. So the input adalah desired, akan diberi oleh user. Dia akan beritahu desired output ataupun dia punya set point, dan the system will work out supaya kita dapat dia punya actual response pada output signals. So control system examples is, for example, a position control. This one is more towards a robotics arm. Crane system dekat yang angkat container daripada satu place kepada satu place. Elevator, the lift system, okay, satellite tracking and so on. Speed control is for the speed of airplane, the washing machine, the climbing robot. Temperature control more towards air condition, heater, furnace. Level control is more towards liquid level of water. Vibration control is more towards the machine vibration, car suspensions, all are considered as a vibration control. And advantage of control system is power amplifications. We can move one container from the ship to the land at the airport. We know that the container is very heavy, so we must use the power applications such as crane to move the container from one place to another place. Remote control, so kita boleh control robot walking dalam laut di atas daratan dengan menggunakan remote control. Okay. Then the remote control of the convenience of input form. Contohnya aircon, kita boleh set temperature pada 25 Celsius atau pada 21 Celsius dengan kita set pada dia punya controller dia, kat room temperature controller. Or we can do compensation for disturbance. Maknanya untuk dapatkan signal yang baik, okay, so kita kena antenna positions kena betul, okay, supaya kita dapat signal walaupun dalam strong wind, present of a strong wind, angin yang kuat. So history of control system dah lama, bermula pada awal 1900 daripada Al-Jazari water clock. Okay, then it goes to the automatic ship steering 1922, then PID controller 1920. Then contemporary, we have a widespread application in the navigation, entertainment, smart homes, military, space applications, chemical process, and nano system. So this is one of the Al-Jazari elephant clock, okay, which is 800 years ago. Okay, invented the Al-Jazari elephant clock. Is the first control system. Okay, so this is one of the example of the Muslim origin modern automation and robotics. Al-Jazari elephant clock. And this clock was in 1136 till 1206, was highly creative and innovative engineer. His crowning achievement was converting a rotational motion to linear and crucial to pumps, engines, and many other machines. So he is known as the father of robotics. Okay. But lately kita dah tak pakai Al-Jazari clock, so kita pakai kepada electrical appliance yang lebih modern dan lebih canggih. Okay, for example a freezer, apa nama ni, iron, smart iron, okay, yang boleh keluarkan steam dan heat, then water heater which can control the temperature of the water through the hot coil, and a washing machine, okay, aircon using a remote control and so on. And you also applied in the contemporary applications in aeroplane, high-speed train, chemical industry, pharmacy industry, semiconductor industry, robotics, and so on. So we have a manual control, which is the old type of control, which is a human-aided control. Operator constantly observe the deviations and make corrections when necessary. It's not consistent, and hundreds of variables to be controlled. Okay, so dia banyak menggunakan mata dan tangan. Mata untuk tengok level of the water tank, and then tangan is to control the door of the valve that flow. Okay, so ni kita panggil sebagai manual control. Jadi kalau kita buat kerja ni daripada graduate sampai ke pencen, buat benda ni je agak bosan juga. So kita kena make it automatic. Okay, so replace the humans with the machines. Or nowadays using computers to implement the control of the plant. Okay, so that's why kita kena measure. So kita kena buat measurement menggunakan sensors, dan kita kena buat decisions dengan menggunakan computers, dan kita kena take action, control actions dengan menggunakan actuators. Actuators adalah penggerak. Contohnya DC motor, contohnya valve. Okay, ini adalah kita panggil sebagai actuators. So control system configurations, kita boleh configure dia sebagai dua type. One is the open loop, the other one is the closed loop. Okay, so open loop maknanya dia start dan dia habis pada satu line sahaja. But closed loop dia tak habis pada satu line, dekat keluaran line keluaran itu akan diberikan feedback masuk balik kepada input untuk membetulkan error ataupun kesilapan. So the open loop control system consists of it's not a feedback, okay, to influence the control actions. Okay? Open loop control system, OLCS. Okay. So with the disturbance or desired response, kalau ada disturbance masuk dalam sistem, so dia tak boleh nak betulkan. Okay. So tak boleh. Maknanya itulah kelemahan open loop control system. So they work based on the time and the result may not be accurate. So you can see that in this block diagram. Okay. So we have the input, then we have the sensors, input transducer, then we have the controller. Then dekat summing junction ni dia ada disturbance one. Mungkin daripada handphone, mungkin daripada plug 3 pin, 50 Hz frequency masuk dalam. Dan dia masuk dalam proses, masuk lagi disturbance kedua, gangguan lagi, masuk lagi. So dua disturbance ni tak boleh buang bila dia dah masuk dalam sistem. So itu adalah open loop control system disadvantage. So in order to overcome that, so the output signal of the closed loop control system is feedback to influence the control action and to improve the overall system performance. So apa yang kita buat adalah dekat keluaran ini kita beri feedback. Kita ambil satu wire, sambung, pergi kepada sensor dan terus masuk kepada summing junction. Jadi dia bezakan, dia akan cari beza dia di antara the input and the output, then dia akan dapat error. So the controller will take action on the error so that we can remove this disturbance 1 and disturbance 2 in the system. So the closed loop control system is shown here, where you have the input, you have the summing junctions, you have the controller, you have the plant, and you have the disturbance. Okay, so set point ini adalah input dia. Manipulated variable adalah pada output controller. Control variable adalah daripada keluaran ini masuk kepada feedback dan dia akan masuk kepada process variable, dia akan bandingkan dengan set point. So that kita boleh reduce error ni dekat keluaran summing junction. So closed loop control system is referred to the short form CLCS. Dia ada input transducer to convert the physical signals to electrical signals. Dia ada output transducer to measure the output response, then compare with the input. Dan dia ada summing junction. Summing junction ini adalah menggunakan operational amplifier yang dikonfigurasikan sebagai penjumlah. Okay, untuk mendapatkan perbezaan di antara input dan output. So the output signal is subtracted from the input signals, which is the error, and ini akan diberikan kepada actuating signals. Okay, so kita nak error ini lagi kecil lagi bagus. Okay, so closed loop boleh compensate disturbance. Okay, dia boleh correctkan error menjadi lebih baik dan boleh memenuhi desired response yang kita nak. So example of liquid level control system is shown here. Okay, you have a liquid here, then it go out. Okay, the valve and the input of the liquid levels. So kita ada set point masuk dekat transducer. So biasanya transducer yang kita pakai untuk level adalah capacitance sensor. Then it will produce the set point. It goes to the controller. It goes to the pump. Pump ini adalah sample actuator. So tadi saya cakap dia ada valve, ada motor, ada pump. Ini semua adalah elemen-elemen actuator. Then masuk kepada sistem, liquid level systems. Then we have a level sensor that will be compared to the set point to produce the error. So apa beza dia di antara open loop dengan closed loop is structure. Open loop simple, closed loop complicated. Sensitivity to parameter variations, open loop sensitive, closed loop less sensitive. Disturbance, open loop cannot handle, closed loop can handle. Application of open loop is limited. The closed loop is various system, most all can be applied closed loop. And cost for open loop is more cheaper compared to the closed loop. You have to add more sensors, add more wires, and it becomes expensive. So examples of control system is shown here. Okay, for signal receiving, okay, for ni biasa Astro lah Tapi saya rasa awak pun tak pakai Astro sebab cerita dia asyik ulang-ulang aja. Okay, so power amplification in this type of antenna. So kita kena adjust antenna ini supaya kita dapat clear signals, okay, daripada satellite. You have to control the robots, okay, using a control system, okay. This is some sample of the Mars robot, and what do you call this? The thermostat of the room air conditioning, and the rolling mill, okay. Disturbance compensation in rolling mill to maintain the steel thickness despite the variations of disturbance. And this is what I told you before in the first slide, the high-speed train suspension systems, okay, which is a complex system, which have fuel tanks, which have a battery box, which have the corridor runs and so on. So ini yang tidak menggunakan magnet. Kalau yang menggunakan magnet, levitation is tak menggunakan fuel tank. Dia menggunakan force magnet untuk bergerak. So in 1.5, we will look into the analysis and design objectives. Okay, so kita akan lihat transient response, okay, stability and steady state error dalam subjek ini. So tidak ada design. Design adalah dalam subjek seterusnya, di mana awak kena pass subjek ini, then barulah boleh ambil subjek design. Okay, so the spec of the transient adalah daripada mula dia respon dia naik sampailah dia menjadi steady state. Steady state itu maknanya dia dah mantap, keadaan mantap, steady state error, ralat keadaan mantap. Steady state respon, sambutan, keadaan mantap. Keadaan mantap tu maknanya dah mantap lah, dah stabil, tak ada kekacauan dan perubahan. Transient dia masih lagi bergolak, masih lagi berubah sebelum menjadi steady state. So kita mesti mencapai objektif untuk satisfactory transient response, a good rise time, a good settling time, a good overshoots. Then the system must be stable. Then the zero steady state error, okay, error sekecil yang mungkin. So objectives macam tadi, kalau kita masuk ke leaf, kita tekan desired response kita, katakanlah pada nombor 8. Okay, dalam bangunan, maka kita akan dapat apa yang kita nak, maknanya pada level. Maknanya kalau kita tekan 8, dia keluar pada level 7, maknanya tak sampai pada desired response yang kita nak. So the process of control system design is first is the classifications, which is the type of signals, the mathematical models, and the control objectives. So based on the purpose of the system and the relevant classes, it belongs to the type of signals, whether it's a continuous or discrete time. So kita berada pada continuous time sahaja. Discrete ini adalah pada level final year elective dan juga pada level masters. Dan mathematical model kita hanya melihat kepada linear control system sahaja, tidak kepada non-linear. Non-linear adalah pada level masters. Dan kita lihat kepada control objektif mau kepada kinetic dan regulating control system. So untuk modeling kita ada dua cara. Satu adalah daripada analytical iaitu daripada derivations, first principles. Dan lagi satu adalah system identifications, based pada data. So kita hanya lihat kepada analytical modeling. System ID adalah pada level masters. Dan kita akan lihat kepada time domain dan frequency domain analysis dalam subjek ini. Controller adalah pada next subjek, di mana awak kena lulus subjek ni baru boleh ambil subjek seterusnya. So this is the control design process. So first step 1, kita transform into the mathematical model, buat block diagram, buat schematic, dapatkan block diagram, reduce block diagram, and then analysis and design. So kita berada pada step ni lah, chapter 1, 2, 3 and 4. Okay, this is some of the examples of the antenna position control system. Okay, which you can read from the books, the Norman Nice book. Okay, and the block diagram to simplify the antenna block diagram. And the software MATLAB. So software ini perlu di install oleh pelajar sebab kita akan gunakan dia dalam assignment dan dalam pembelajaran. Okay, so please install this MATLAB software. Scilab dengan LabVIEW tak perlu. Okay, one of the program learning outcome, PLO4, adalah ability to work with modern instrumentation, software and hardware. And then we have to use MATLAB in analyzing control system performance. Okay, this is some of the control system software using Windows. And then the Simulink as well. Okay, some review questions for you to think about after these slide introductions. Application of feedback control system, open loop system, closed loop system. Okay, approach to make a mathematical model. How do we classify control system? So ini macam soalan quiz lah, tapi untuk jawab sendiri. Okay. Some problems. Okay, temperature control system problems, which using thermostat control. Okay, and then this is the end of chapter 1. Okay, so kita berehat sebentar. Okay, kita berehat sebentar. Saya akan mula balik pada pukul 10 pagi. Boleh? Halo?
Okey, Prof. Boleh.
Okey, Prof.
Boleh. Makan dulu, pukul 10 kita masuk.
Okey, Prof. Boleh.
Jom, kena masuk balik lah. Saya tutup dulu.
Okey.
Saya end dulu, nanti saya suruh masuk balik.
Boleh.
Okey, Prof.
Okay, sarapan dulu.